Then another question from IIT JEE PYQ. The question is from the chapter Newton laws of motion, and here is the question. A particle P is sliding down a frictionless hemispherical bowl. It passes through the point A at t is equal to 0. So at a t is equal to 0, this point, this mass P is here, such that its horizontal component of velocity is v. So here it is having an horizontal component of velocity v. Okay, it passes through the point A at t is equal to 0, and it is having a component of horizontal component of velocity v. At the same time, a bead q of the same mass as p is ejected from this point A at t is equal to 0 along the horizontal line AB with same speed. So this q is being ejected in this direction with the same speed v. Horizontal speed is v. Now we have to tell, let Tp and Tq be the respective times taken by P and Q to reach this point B. Now we have to tell the relation between them. Which one will be greater and which one will be lesser time it will take. So let me take the condition here for bead this Q. Okay, this is our point A and this is our point B. Now this is the bead of mass m here, that is Q bead, and it is having an horizontal velocity v. Let us suppose this distance between this A and B is L. Okay, so here time taken by this Q bead to reach here at AB, that will be equal to what? TQ will be equal to L by V. Okay, let me say this is the R equation number 1. Now the main point is to understand the analytical approach for this bead Q. So this is our hemispherical bowl here, and this is our point A, this is our point B, and let me divide it into the two parts. Initially our bead, that P bead, this is our P bead, is here, and it was having an horizontal component of velocity v in the right direction, right? Now let me assume an intermediate situation like here at this point. Then what will be the forces acting on this bead? One will be this mg, that is acting in downward direction. One will be a normal acting in this direction. Now just like a reasoning approach, I can assume that the resultant of these two forces will be in this direction, somehow in this direction. Okay, this normal and this mg. Okay, so obviously at this point P, if I assume this is the middle point C here, so at this point A, its horizontal component of velocity was v. Okay, so there is a component of net force acting in the horizontal direction. So obviously from point A to point C, if here is the horizontal component of velocity is v, then at C horizontal component of velocity will be v dash. Okay, and this v dash will be always greater than this v, because there is an horizontal force acting on this body that will give it some acceleration in the horizontal direction, and due to which this body will gain some velocity. Okay, now let us suppose at C point this body is having that velocity v dash, that is greater than v. Now again I will assume an intermediate situation between this point C and B. Okay, now here what are the forces acting on this body? One will be again this mg force, and one will be this normal reaction. Okay, similarly there will be a resultant of these two forces, and I can assume that there will be an horizontal component of this resultant of this normal and this mg. Okay, so here is the velocity v dash at point C. It will reduce and it will come to this point B, and here at point B the horizontal component of velocity will be v only. Okay, so this v will be less than this v dash. Okay, so from A to B, from A to C, the horizontal component of velocity was increasing up to the instant v dash, and from C to B horizontal component of velocity was decreasing. Okay, and here it was increasing. But one thing we have to keep in mind that in any intermediate situation, the horizontal component of velocity was always greater than v. Okay, so I can clearly write here that in between a and b, horizontal component of velocity of this particle p was always greater than this horizontal component v. So here I can clearly write, if this distance between this a and b is l, then time taken by this particle p to come from a to b, that will be equal to l by this velocity. Okay, let me call it v dash. Okay, I am just giving it a connotation here, that v dash. Here v dash was always greater than this v, horizontal component velocity. So from the equation number 1, that tq was there, and this is our equation number 2, I can clearly say that tp will be less than tq. Okay, so here particle p will take less time in moving from a to b. Okay, here so tp is less than tq, that means which option is correct for us? Our option A is correct. Okay,